Hi everyone, this is ChainGuru and welcome back to our channel. Today, we will be delving into one of the most critical areas of supply chain management, supply chain strategy and design. This session is essential because the way a supply chain is structured and managed has a profound effect on a company's overall performance and competitive advantage. Whether you're manufacturing automobiles, designing smartwatches, or selling sportswear, the supply chain is at the heart of delivering value to customers. From a logistics perspective, this becomes even more crucial. Logistics, encompassing transportation, warehousing, inventory management, and order fulfillment, serves as the operational backbone of the supply chain. Efficient logistics ensure that materials and products move smoothly from suppliers to manufacturers, and from distribution centers to end customers. Poor logistics design can result in delayed deliveries, increased costs, stockouts, and unhappy customers, undermining even the best business strategies. Conversely, a well-integrated logistics system allows companies to reduce lead times, optimize costs, and respond rapidly to market demands. In today's global and fast-moving markets, logistics is no longer just a cost center, it's a strategic function that can make or break a company's competitive position. Our key topics for today include the strategic role of the supply chain, supply chain drivers and metrics, push versus pull systems, types of supply chains, supply chain network design. Let's begin. The supply chain is not just a support function, it is a strategic tool that can create significant competitive advantage. At its core, the supply chain encompasses all activities involved in fulfilling a customer request, from the procurement of raw materials to the final delivery of finished products. It includes a complex network of suppliers, manufacturers, transporters, warehouses, retailers, and customers, each playing a vital role in ensuring products reach the market efficiently and effectively. Strategic approaches differ based on industry, market, and regional context. To demonstrate this concept, today, we will use Nike and Toyota as examples to see if there is any difference in their supply chain strategy. Take the example of Nike. Their supply chain is carefully designed to provide high levels of responsiveness to fast-changing fashion trends while maintaining cost efficiency. Nike outsources most of its manufacturing to specialized contract manufacturers located in various low-cost countries. This approach allows them to remain asset-light and highly flexible. By not owning production facilities, Nike can scale operations up or down based on seasonal demand and emerging trends. Furthermore, their use of real-time data from global retail outlets helps them adjust supply rapidly. This responsiveness, combined with strategic sourcing and centralized logistics, enables Nike to maintain a competitive edge in the highly dynamic sportswear market, balancing innovation, speed, and cost control. Why is this strategic? Because it allows Nike to scale production up or down quickly. It reduces the financial risk associated with owning manufacturing assets. It enables Nike to focus on core competencies like design and marketing. In contrast, Toyota's supply chain is built around the principles of lean manufacturing, a philosophy that emphasizes the elimination of waste, continuous improvement, and the efficient use of resources. Central to Toyota's lean strategy is the just-in-time (JIT) system, which ensures that each component is delivered to the production line exactly when it is needed, in the exact quantity required. This approach significantly reduces the need for large inventories, freeing up capital and minimizing the risks of excess stock or obsolescence. Toyota's JIT system also fosters close collaboration with suppliers, who are often located near production facilities to support rapid, synchronized delivery. This proximity and integration help Toyota quickly adapt to production changes and maintain high product quality. In addition, their use of standardized processes and a strong focus on quality control throughout the supply chain reduce defects and rework costs. This lean and tightly coordinated supply chain has been a key driver of Toyota's global success, allowing it to produce reliable vehicles efficiently, respond flexibly to customer demand, and maintain a reputation for high quality in the fiercely competitive automotive industry. Nike and Toyota represent two distinct supply chain strategies shaped by their industry dynamics and business goals. Nike operates in the fast-paced, fashion-driven sportswear industry, where customer preferences change rapidly. To stay competitive, Nike emphasizes flexibility and responsiveness. It outsources manufacturing to remain asset-light, leverages global suppliers, and uses real-time sales data to adjust production quickly. This agile model allows Nike to innovate frequently and deliver new designs to market swiftly. On the other hand, Toyota, in the highly competitive and capital-intensive automotive industry, prioritizes efficiency, quality, and cost control through its lean manufacturing approach. Central to Toyota's strategy is the just-in-time (JIT) system, which minimizes inventory, reduces waste, and ensures precise coordination with suppliers. This approach enhances operational efficiency and product reliability. In summary, Nike's supply chain supports rapid market responsiveness, while Toyota's is optimized for operational excellence, highlighting how strategy must align with product type, customer expectations, and market conditions. So the key takeaway for this session is, a well-designed supply chain aligns with business strategy to enhance customer satisfaction and improve profitability. To manage and design an effective supply chain, we must understand the key drivers and how to measure their performance. A key driver in the supply chain refers to a fundamental element or lever that directly influences the overall efficiency, responsiveness, cost, and service levels of the supply chain. These drivers are the building blocks that determine how well the supply chain performs in meeting business objectives and customer needs. The 6 primary drivers are: facilities, the physical locations where products are stored, assembled, or fabricated. Example: Adidas has centralized warehouses in Europe to reduce inventory and lead times. Inventory, the raw materials, work in progress, and finished goods within the supply chain. Example: Apple strategically holds inventory of critical components like chips to manage supply volatility. Transportation, the movement of inventory from point to point in the supply chain. Example: Tesla uses a mix of ocean, rail, and trucking for global distribution, optimizing for cost and speed. Information, data and analysis regarding inventory, transportation, customer demand, and market trends. Example: Zara uses real-time sales data from stores to adjust production and inventory. Sourcing, the selection of suppliers and purchasing of goods and services. Example: Samsung has dual sourcing strategies to mitigate risks in their smartphone supply chain. Pricing, the methods by which a firm prices its products or services. Example: Uber uses surge pricing to balance supply and demand dynamically. Measuring supply chain metrics is essential for evaluating the performance of key drivers and ensuring that the supply chain aligns with overall business goals. These metrics provide quantifiable insights into operational efficiency, customer service levels, cost control, and the ability to respond to market demands. Without clear performance indicators, decision-makers lack the visibility needed to identify inefficiencies or optimize processes. Metrics are the foundation of continuous improvement and allow companies to benchmark against industry standards or track progress over time. One critical metric is inventory turnover, which measures how often inventory is sold and replaced over a given period. High turnover typically indicates efficient inventory management and strong product demand, while low turnover may suggest overstocking or slow-moving goods. Order fulfillment cycle time evaluates how quickly customer orders are processed, packed, and delivered. Shorter cycle times improve customer satisfaction and reflect responsive operations. The perfect order rate measures the percentage of orders delivered on time, complete, and without errors. A high perfect order rate signals operational excellence and reliability. Supply chain cost as a percentage of sales is another vital metric, highlighting how much of a company's revenue is consumed by logistics and supply chain activities. Lower percentages indicate better cost efficiency. Finally, forecast accuracy assesses the ability to predict demand correctly. Inaccurate forecasts can lead to excess inventory or stockouts, both of which harm profitability. In sum, these metrics provide a structured framework for managing supply chain performance and making informed, strategic decisions. So the key takeaway for this session is, drivers must be managed in harmony, and metrics help in continuously evaluating performance and making improvements. Let's now discuss push versus pull systems, which are fundamental concepts in supply chain logistics, especially when planning production, inventory, and distribution strategies. These systems reflect two contrasting approaches to managing the flow of materials and products through the supply chain, and understanding them is crucial for aligning supply chain design with business goals, customer expectations, and product characteristics. The push system is forecast-driven. Companies estimate future customer demand using historical data, market analysis, and planning tools, then manufacture and distribute goods based on these projections. Products are pushed through the supply chain, from manufacturers to distribution centers, retailers, and finally to customers, regardless of real-time demand. From a logistics perspective, push systems enable bulk production and long-haul transportation, allowing firms to benefit from economies of scale and efficient resource utilization. For example, Samsung forecasts smartphone demand months in advance, manufactures in high volumes, and distributes globally. However, push systems also pose risks, such as overproduction, high inventory holding costs, and the threat of obsolescence in fast-moving markets. In contrast, a pull system is demand-driven, where production and logistics activities are initiated by actual customer orders. Products are made or moved only when there is a confirmed need. This model is ideal for industries with high customization or volatile demand. Dell famously adopted a pull approach by building PCs only after receiving customer specifications. While pull systems reduce inventory waste and increase responsiveness, they require agile logistics, tight coordination, and advanced information systems. Most companies today use a hybrid push-pull model to strike a balance. For instance, Zara produces staple items in bulk, push, but reacts quickly to fashion trends through local manufacturing, pull, ensuring both efficiency and agility. Ultimately, choosing the right push-pull mix is essential for optimizing logistics operations and maintaining a competitive edge in dynamic markets. So the key takeaway for this session is, the choice between push and pull affects responsiveness and efficiency. Businesses must find the right balance for their industry and product type. There are various types of supply chains, each designed to support specific business models, customer expectations, and market dynamics. The effectiveness of a supply chain type depends on how well it aligns with the company's products, demand patterns, and strategic priorities. Here, we'll explore 4 key types: lean, agile, responsive, and efficient supply chains. Each has unique characteristics, benefits, and trade-offs, especially from a logistics and operations perspective. The first one is the lean supply chain. A lean supply chain focuses on cost efficiency and waste elimination. It aims to streamline operations by reducing non-value-added activities and minimizing excess inventory. Lean systems are most effective in stable, predictable environments where customer demand is relatively constant. A prime example is Toyota, whose production system embodies lean principles through its just-in-time (JIT) strategy. In Toyota's case, parts arrive exactly when needed, reducing storage costs and ensuring high levels of efficiency. From a logistics standpoint, lean supply chains require tightly coordinated transportation schedules, precise supplier collaboration, and minimal warehousing. The system emphasizes continuous improvement and quality control, but it can be vulnerable to disruptions if suppliers fail to deliver on time. The second one is agile supply chain. An agile supply chain prioritizes flexibility, adaptability, and responsiveness, making it ideal for industries with volatile demand, high product variety, and short life cycles. Fashion retail is a classic example, and Zara stands out with its agile approach. Zara responds to customer preferences by designing, producing, and delivering new styles in a matter of weeks. From a logistics perspective, agility means having the ability to shift sourcing, production, and distribution quickly. Zara leverages local manufacturing and responsive logistics hubs to replenish stores twice a week. The logistics network must support speed and flexibility, often at the expense of lower cost. Agility also requires strong information systems for real-time demand tracking and inventory visibility. The third one is the responsive supply chain. While similar to agility, a responsive supply chain puts greater emphasis on speed. It is tailored to deliver products quickly, often with high service levels and short lead times. This is particularly important in e-commerce, where customers expect rapid delivery. Amazon Prime is a prime example. Amazon has invested heavily in a global network of fulfillment centers, advanced routing algorithms, and last-mile delivery capabilities to enable same-day or next-day delivery. Responsive supply chains depend on cutting-edge technology, advanced logistics coordination, and significant infrastructure investment. They are particularly effective in environments where customer satisfaction hinges on delivery speed. Finally, the efficient supply chain. An efficient supply chain seeks to maximize productivity and minimize cost, especially through economies of scale, bulk purchasing, and streamlined processes. It is best suited to high-volume, low-margin products with stable demand. Walmart exemplifies this model by using a centralized distribution system, strong supplier relationships, and data-driven replenishment. From a logistics standpoint, Walmart's model emphasizes freight optimization, cross-docking, and inventory control to reduce costs. The goal is not speed or flexibility, but consistent low-cost delivery. In summary, different supply chain types serve different strategic needs. A lean supply chain is best for cost and stability, agile for flexibility, responsive for speed, and efficient for low-cost, high-volume distribution. Businesses often blend elements of each to create a hybrid model that matches their unique market demands, product characteristics, and operational capabilities. Logistics plays a central role in shaping and enabling these strategies, ensuring that products move through the chain efficiently, responsively, and reliably. Designing a supply chain network is one of the most strategic decisions a company can make, as it directly impacts service levels, operational efficiency, responsiveness, and overall cost. A supply chain network includes the physical configuration of suppliers, manufacturing facilities, warehouses, distribution centers, and retail outlets, as well as the transportation routes and logistics services that connect them. The goal of supply chain network design is to structure and position the key elements of the supply chain, such as suppliers, manufacturing facilities, warehouses, distribution centers, and transportation routes, in a way that best supports the company's overall business strategy. A well-designed network ensures that products flow efficiently and cost-effectively from origin to end customer, while also meeting service-level expectations. Primarily, the network should support the strategic goals of the business. For example, a company focused on speed and customer experience might prioritize decentralized warehouses near key markets. In contrast, a cost leader may concentrate production in low-cost regions to maximize economies of scale. Additionally, network design should optimize both cost and service performance. It requires balancing the trade-off between low logistics costs, such as bulk shipping and centralized storage, and high service levels, such as fast delivery and product availability. Finally, a robust network enhances responsiveness and adaptability, enabling the company to react swiftly to market changes, supply disruptions, or demand spikes. A strategically designed supply chain network is a competitive asset that provides both stability and flexibility in today's volatile global market. Key decisions in network design involve determining the number, location, and function of each node in the supply chain. Should a company have one large, centralized warehouse or several smaller regional ones? Should manufacturing be located near raw materials, near customers, or in low-cost regions? The first consideration is the cost of the facilities and the labor. Operating costs are a critical factor in supply chain network design, and they vary widely from one region to another. When deciding where to locate facilities such as factories, warehouses, or distribution centers, companies must consider several cost components. These include labor costs, which can represent a significant portion of total operational expenses, especially in labor-intensive manufacturing. Regions with lower wages, such as parts of China, Vietnam, and other Southeast Asian countries, offer attractive savings for companies aiming to produce at scale. Beyond labor, utilities, such as electricity, water, and gas, land prices, and tax policies also play major roles. In some regions, governments provide tax incentives or subsidies to attract foreign investment, which can significantly reduce operating expenses. Conversely, high property prices or stringent regulatory requirements in certain developed markets can increase the overall cost of running a facility. A good example is Apple, which strategically locates its final assembly operations in China. The country offers not only cost advantages in labor and infrastructure but also a well-established supplier base. This allows Apple to achieve economies of scale while maintaining tight control over quality and logistics. Therefore, operating cost analysis is essential in making informed, strategic decisions that align with both financial objectives and global supply chain performance. The second consideration for the supply chain network design is the proximity to customers and suppliers. Proximity to both customers and suppliers is a vital consideration in supply chain network design, particularly for companies that prioritize responsiveness, speed, and cost efficiency. Being physically closer to customers allows firms to shorten delivery lead times, enhance service levels, and reduce last-mile transportation costs, which are often the most expensive segment of distribution. This proximity not only improves customer satisfaction by enabling faster order fulfillment, but also increases a company's ability to respond to changes in demand, seasonal fluctuations, or special promotions with agility. On the other hand, proximity to suppliers is critical for optimizing inbound logistics. Close geographic alignment with suppliers enhances coordination, minimizes shipping time and cost, and enables more efficient scheduling of materials and components. This is especially beneficial in industries that rely on just-in-time (JIT) manufacturing systems, where timely delivery of inputs is essential to avoid production delays or excess inventory. For example, automotive manufacturers often establish production facilities in industrial clusters, surrounded by key component suppliers. This setup supports lean manufacturing by reducing the dependency on long-distance shipments, lowering risk, and enabling tight production control. Overall, strategic proximity enhances both efficiency and responsiveness throughout the supply chain. The third consideration is obviously the transportation costs. Logistics costs represent a significant portion of total supply chain expenses, often accounting for transportation, warehousing, handling, and packaging. Therefore, when designing a supply chain network, one of the most critical decisions involves determining the most cost-effective transportation modes and routes. Whether goods are moved by truck, rail, sea, or air, each mode has different implications for cost, speed, and flexibility. For example, ocean freight is economical for bulk international shipments but slower, while air freight is fast but expensive, making it suitable for high-value or time-sensitive products. For bulky or heavy goods, transportation costs rise steeply over long distances, especially in the final leg of delivery, known as the last mile. To manage this, companies strategically position facilities like warehouses and fulfillment centers closer to customer hubs to reduce distance, time, and fuel consumption. A prime example is Amazon, which has built a vast network of regional fulfillment centers across key markets. This structure allows them to optimize shipping routes, reduce last-mile delivery expenses, and still provide same-day or next-day delivery. Thoughtful logistics planning in network design helps companies strike the right balance between service speed and operational cost, boosting both customer satisfaction and profitability. Most of the companies nowadays are global-facing. Global trade policies are a critical factor in supply chain network design, as they directly impact the cost, reliability, and feasibility of cross-border operations. When choosing facility locations, companies must evaluate import, export duties, customs regulations, trade agreements, and political stability. These elements can either facilitate or hinder the efficient movement of goods. For instance, free trade agreements, FTAs, between countries can lower tariffs, reduce paperwork, and speed up customs clearance, making some regions more attractive for investment. On the other hand, protectionist policies or escalating trade tensions can impose significant costs and uncertainties. A prominent example is the US-China trade tensions, which have led many companies to restructure their manufacturing footprints. To avoid rising tariffs and reduce exposure to geopolitical risks, firms have begun shifting production to alternative locations such as Vietnam, India, and Mexico. This strategy, often called China Plus One, helps companies maintain global market access while improving resilience and controlling costs in an unpredictable trade environment. After those theories and concepts that I just explained, let us use Apple as an example. Apple's supply chain design is a world-class example of a globally integrated yet strategically centralized network. The core of Apple's production process, final assembly, is largely concentrated in China, predominantly through its long-standing partnership with Foxconn, a major contract manufacturer. This centralization allows Apple to capitalize on lower labor costs, robust manufacturing infrastructure, and scalability, enabling mass production with high levels of precision and efficiency. China's industrial ecosystem, particularly in regions like Shenzhen, offers a deep network of component suppliers, skilled labor, and logistics support, making it an ideal location for assembly operations. However, Apple's reliance on China is balanced by a globally diversified supplier base for critical components. For instance, processors are designed by Apple in California and manufactured by TSMC in Taiwan. Displays are sourced from Samsung and LG in South Korea. And other specialized parts like camera modules and sensors are procured from suppliers in Japan and the United States. This distribution allows Apple to access cutting-edge technologies, maintain quality standards, and avoid overdependence on any single region. This hybrid model provides several strategic advantages. Centralizing assembly enables Apple to control costs and maintain operational consistency, while global sourcing allows for innovation, risk diversification, and supply chain agility. Moreover, Apple's use of logistics hubs and regional warehouses helps it meet global demand efficiently, ensuring fast delivery and inventory responsiveness. In summary, Apple's supply chain exemplifies how thoughtful network design can integrate cost efficiency, technological excellence, and global flexibility. It highlights the importance of aligning supply chain strategy with business objectives, especially in a high-demand, innovation-driven market like consumer electronics. Finally, to wrap up today's session, we've covered the essential components of supply chain strategy and design. Let me summarize into 5 points. The supply chain is a strategic asset that must align with business goals. Drivers and metrics provide levers and tools for improvement. Push and pull systems have distinct advantages and must be balanced. Different supply chain types suit different markets and products. Network design decisions are foundational to performance and resilience. In a rapidly changing world, supply chains must be dynamic and adaptive. Whether it's a global pandemic, trade war, or shifting consumer trends, those who invest in supply chain strategy and design will be the ones to thrive. Hope that you have some takeaways from today's session. Please feel free to raise your questions or comments down below the session. Don't forget to subscribe and hit the like if you are new. I will see you in the next session. Take care. Bye.